This video is on the objective: determine the degrees of freedom to find and interpret the t-score of a normally distributed random variable with your calculator. And this is number 2. This is the second video I've done on this kind of question in your Newton Alta homework. So this one will be pretty quick. I'll just go straight to the calculator and use that inverse t, right? The way I like doing it, I don't like doing it the way they do it. You can look at more instruction and see how they're doing it, and if you like that, you can do it. Click on more instruction here, see how they enter stuff. But if I'm just asked for simply a simple t-score, I'm just going to go straight to that inverse t function on the calculator. Alright, so here the number of square feet per house are normally distributed with an unknown population mean and, again, unknown standard deviation. So we're dealing with the student's t distribution, not the standard normal or z distribution. That's when sigma was known. Alright, if a random sample of 33 houses is taken to estimate the mean house size, or the population mean, use a calculator to find the t-score that should be used to find a 90% confidence interval estimate for the population mean. Alright, so remember, to find a t-score when we know certain areas, I'm going to use that inverse t. So let me pull the calculator up. Let's get rid of this last problem. All right, so remember, I go second, distributions, and down to number 4, inverse t. This area it's asking for is the area to the left of the z-score, the t-score that I want. Now, the confidence level is 90%. Right, so that means there's 90% of the curve, under the curve, 90% between the upper value of the confidence interval and the lower value. Now, if there's 90% between, that means there's 10% left, right? Alpha, the value of alpha would be 10%, and you cut that in half, alpha over 2 would be 5%. So the area above the upper value would be 5%. The area below the lower value would be 5%. So I'm looking for a t-score with 5% above it. I'm looking for the t-score with 5% above it. Now, if you got 5% above, that means you have 95% below, right? So for the area here, I'm going to enter 0.95. Remember, it's area to the left, area below that's entered in the calculator. So 5% above means 95% below. Degrees of freedom, remember, degrees of freedom depends on the sample size for every one of these students' t distributions. And it was, for one sample, for one population, it was the number of the sample size minus 1. So it said they took a sample of 33 homes. So I'm entering 32 for the degrees of freedom. And if you have an older calculator, this is what you'll have to enter: the area to the left of your t-score, comma, and then the degrees of freedom. And there you go. Here's the t-score that would be necessary to determine the margin of error for my confidence interval, right? If I remember, the margin of error was this t-score times s over the square root of n, right? The sample standard deviation divided by the square root of the sample size. But this is how many standard deviations above the mean and how many standard deviations below the mean those values, those lower and upper values of the confidence interval are. All right, so 1.694 if I'm rounding to 3 decimal places like they want. So the t-score necessary to calculate a confidence interval here would be 1.694. And submit. And again, you can look at the way they're doing it, which is a little different. They use the t-interval and all that, but you can look at the way they're doing it to get 1.694. I personally like just using the inverse t because you're only asked for a t-score. And yeah, so hopefully the way I did this here, and again, if you want to read the answer explanation, go to more instructions, see how they're doing it, do it that way, that's fine. But my way with inverse t is totally fine as well. So hopefully that helps you, when you're coming across problems like this. And thank you very much for watching.